A claim is a name-value pair that represents what the subject can do, not what the subject is. When implementing claims-based authorization, instead of defining a set of roles that can be assigned to users, we define multiple permissions and then have the ability to grant those permissions to individual users. In our application so far, we assumed that only users with the admin role can create, update, and delete coffees. Claims-based authorization comes in handy when we need more granular control and, for example, want specific users to be able to create and update coffees, but only one specific supervisor user has the capability of deleting coffees. So let's switch to our IDE and start by creating a new coffees.permission.ts file in the coffees directory. Inside this file, let's create an enum representing all coffee-related permissions. You can find the code below the course video. Note once again that typically, you'd store these permissions in a dedicated database table. Okay, so let's save our changes and navigate to the IAM authorization directory. Here, let's create another file called permission.type. And in this file, let's declare the permission constant and make it equal to an empty object. Inside this object, let's use the spread operator on our coffee's permission enum, making all the permissions available in the permission constants. Let's also export the permission type here so we can use it as an input argument type of our decorator. Now, let's implement the permissions decorator that indicates which permissions are required in order to access an annotated endpoint. As we've already created a few decorators in this course, we'll be following the same syntax to create our permissions decorator. You can find the code here below the course video. Perfect. Now, let's create our permissions guard. And just like our roles guard, it's almost identical, so we won't need to look at everything line by line again. But note that the only main difference here are that we're grabbing the permissions key and checking the user's permissions against what was passed into the decorator. One other important thing that's different in our permissions check here compared to our roles guard is that instead of using the sum method, we want to use every, which makes sure that the user has all required permissions assigned, not just one of them. Also, since users can have multiple permissions, instead of using triple equals, we're using the .includes method here, and that's it. With our permissions guard in place, let's now open up the IAM module and temporarily replace the roles guard with our permissions guard, just to keep things simple for the sake of this lesson. Alright, now the only remaining step is for us to add the missing permissions column to our user's entity. Let's open it up and add it right below the existing roles column. Note, as we've already mentioned before, in a real-world application, you would likely have a dedicated permissions table where you'd store app-specific permissions. Also, instead of storing users' permissions in a JSON column, there would be a many-to-many relationship between the users and the permissions table. Just as we mentioned in the last lesson, if you'd like to practice, go ahead and create the entity, controllers, relations, etc. to establish all of this if you'd like. Another common approach for permissions is to tie permissions to roles themselves. That's a slightly different technique and requires a different configuration, but might be a better fit for certain systems. In this different approach, you could keep using the role-based access control implementation with the roles guard, and each role would have to specify its set of permissions tied to it. Back to our code, as you can see in the comment above the permissions column, having this column in combination with a role does not make sense. We use both in this course just to showcase two different approaches to authorization, but in your application, you should decide which approach you'll take. Okay, so next up, let's open up our active user data interface and add the corresponding permission field there as well. And last but not least, we need to open up our authentication service again and make sure we include the permissions field in the signed async token. Note that once again, this is far from ideal. Embedding a large array of strings into our token will lead to a long, non-lightweight token. In a real-world application where you store permissions in the database, you should only include an array of IDs here instead. Moreover, if you expect a lot of permissions in your system, perhaps you shouldn't embed it in the token at all. In most cases, We'd want to have these stored in a database, and we would retrieve these permissions on each action or request. Alright, with this column in place, let's save our changes, open up the coffee's controller file, and instead of using the roles decorator on top of our create method, let's use permissions now instead, passing permission.createCoffee as an input argument. Let's save our changes, head over to Insomnia, and start things off by first retrieving a new access token. Once we get the response, let's update our authorization header again with the newly received access token and hit the post/coffees endpoint, just like in the last lesson. Great. We received a 403 forbidden error, just as we should expect, since our user does not have any permissions assigned to it yet. To fix this up, let's switch back to our IDE, open up our terminals, and using the REPL again, let's add the create_coffee permission to our user. Note if you're getting any errors like property permissions was not found in user, you may need to restart your REPL session, meaning close the window and run it again. Let's get the user repository, update user1, and add permissions, create_coffee to it. Great. Now back to Insomnia. Let's retrieve a new token again, making sure these updated permissions are embedded in it. Let's grab the token and update that authorization header one last time and hit the coffee's post endpoint once again. We'll see that voila, it works. Our permission system is all set up and working properly. So, as we've mentioned in this lesson, there's a lot of different techniques and approaches to claim-based authorization and role-based access control. Here in this lesson, we have both as we've built on top of the same project we used in the previous lesson. But in a real-world application, you'll likely just need one or a slightly different combination like we mentioned briefly a moment ago, where permissions are associated with roles themselves and not users directly.